Okay, so today arc length and sector area. We're going to be talking about just parts of a circle. Okay? So the arc length, if we have a circle, okay, so if we have a circle, and let's go ahead and draw a arc on this circle. Let's call it arc AB. The arc length is just referring to the length, the actual length in inches or centimeters or feet of that arc. Okay. So of this green segment right here. Now the idea here is that arc is part of the whole circumference. Right? It's a fraction of the whole circumference. It's not the whole thing. It's a fraction or a percentage of it. Okay? And so recall, if we have this angle, then we know this arc measure in degrees. Thank you. And if we know the radius of the circle, then we can get the whole circumference. And so we end up with this kind of formula for arc length of a arc. Okay? It's the measure of the arc in degrees divided by 360. So that gives us what portion of the whole circle this arc is. It's a ratio. Times the whole circumference, times 2 pi r. Okay? So let's do a couple of examples. So notice arc AB is what we want to find. This central angle is the same as the arc measure. And so according to this formula, the arc length of AB, so AL is arc length of arc AB, is equal to the measure of arc AB, which, notice the measure of arc AB is just 60 degrees. So we have 60 over 360. So how much of a circle is it? What fraction of the whole circle? We'll go and do 60 divided by 360. And tell me what that is. Good. So this is 1/6 of the circle. So we would expect the circumference to be 1/6 of the circumference of the circle. So that's what we're doing here. We're getting 60 over 360, which is 1/6, times the circumference, which is 2 pi r. 1 pi times 5. Okay? And so we just put that into our calculator. 1/6 times 2 pi times 5, and we get 5.236. Example 2 says find the length of arc AB. Well, again, here's arc AB. We're not given the measure of this central angle. We don't know what that is. Instead, we know the measure of this what's this called again? Major arc, right? So we know the major arc, so how do we get the minor arc? Okay, so the measure of arc AB will be 360 minus 240, which is 120 degrees. So this arc up top here that we're looking for is 120 degrees. Once we know the angle measure of that arc, well, then the arc length is the measure of that arc over 360, so that's the fraction of the whole circle, times the circumference of the whole circle. So the arc length of AB would be 120 over 360. Now what fraction is that? What's 120 over 360?
360. No, 260.
1/3, right? So this is a third of the circle. Okay, so 1/3 times 2 pi times 12. So you get 25.133. So notice if we're looking for the arc and we're given the central angle, then that's the same, right? If we're looking for an arc and we're given the other part of the circle, then we find the missing arc and then use this one. Sectors are similar idea to arcs in the sense that we're still talking about a part of a circle, but rather than talking about the length of this line, if we have a circle and we want to talk about the sector, the area of the sector, then we're talking about the area. So what's the area of that shaded part? So if this is a, lowercase a, capital A. Okay, so again, if we have arc AB, we want to know what's the area of this sector. We're looking for what's the area of this part of the circle. Maybe like a slice of pie or a slice of pizza. What's the area of that slice? Now it's a similar idea. If we know the measure of this arc in degrees, well, we can figure out what part of the whole circle it is by dividing that by 360, because there's 360 degrees in the whole circle. Okay, so we get the part divided by 360 times the area of the whole circle, so times pi r squared. Okay, again, radius hopefully is given to us, or we can find it. All right, so let's do two examples of this one. Okay, shaded area. So this time, notice since the central angle is 60, the arc is 60. Okay. And so I'm going to say the area of the sector. There's not really good notation for some of this stuff, so just put A sub sector. Well, we're talking about 60 degrees out of 360 total. So that's that fraction of the whole circle times the area of the whole circle. So pi times 4 squared. Now again, what fraction of the whole circle is this slice? 1/6. So this is, just finding the area of 1/6 of a pizza kind of thing. Okay. And so 360 over 360 times pi times r squared, and we get 8.378 square yards. Now, what kind of arc is this one? A major arc. So if we know the minor arc, how do we get the major arc? Okay, so I'm going to say the measure of that arc. It doesn't have a name. It's not labeled. I'm just calling it the arc. Would be 360 minus 120, which is 240 degrees. Okay, so the area of that sector, well, this arc is 240 degrees, and that's the shaded part. All right, so we have that out of 360. So 240 out of 360 times pi times the radius, which is 6 squared. And so we get 75.398 square feet. Okay, so for sector and arc length, it's the same idea. The difference is, rather than finding, it depends on if it's sector, we're using pi r squared times the portion of the circle. If it's arc length, it's 2 pi r. That's the area versus circumference. Now a segment is still dealing with the circle. Okay, so if we have a circle, and if we have a chord drawn in that circle, then when we refer to the sector, we're talking about the area of the circle that's between the edge of the chord. So that's what we're referring to. And so the idea for this is, if we have the center of our circle there and we draw the radii to those points that are on the chord, then what we're going to do is we're going to get the area of the whole sector, right? I'm going to erase this in a second, but the area of the whole sector, and then we're going to cut out this triangle. We get the area of the whole sector, and we subtract the area of this triangle, then we have the area of this segment right here, or this segment right here. Now there's going to be a really useful formula we're going to use right here. If this is our radius, and this angle, the central angle, I'm going to call it theta. So the central angle there is theta. And then notice that this is r, and so is this, right? So this triangle has two congruent sides. So what kind of a triangle is this? An isosceles triangle. There's a really useful formula for areas of an isosceles triangle if we know the angle right here between the two sides. And that area formula, so I'm going to write that down. Area of the triangle is equal to, and normally it's 1/2 base times height. Okay, but since it's an isosceles triangle and we have an included angle right here, the area is also 1/2 r squared times sine of theta. So this is the area of an isosceles triangle where we know the lengths of the congruent sides and the angle between them. We're just going to use that one. Okay. So it says find the area of the shaded segment right here. All right. So to find that area, we have to get the area of the sector, right? So for the area of the sector, we need the arc measure, right? So we need the arc measure right here. Okay, so the measure of that arc would be 360 minus 270, which is 90. So this is 90, which means that this central angle is 90. Okay. So the area of the segment, again, not very good notation for this, I'm just going to call it A sub seg, is the area of the sector, right, minus the area of the triangle. So for the area of the sector, we have our arc measure, which is 90 degrees, out of 360 degrees, times pi times our radius squared. All right, that's the area of the sector. Minus the area of this triangle. Now the area of that triangle, notice this is 5 inches, so is this because it's a circle. All right, so these are the same. And so we have this situation up here where we've got the radii and the angle between them. So what is theta for this particular triangle? 90. And so we're going to say 1/2 times radius squared, which is 5 squared, times the sine of 90 degrees. Now, really quick, someone tell me what sine of 90 is. Did you calculate what sine is?
30. It's 30.
It's 1. Sine of 90 is 1. Okay. Now notice, this is a right triangle. And so this is the base of the triangle, and this is the height of the triangle. So the area formula would be 1/2 base times height. So 1/2, 5 times 5. 1/2, 5 squared. And this is just 1. So this works for a right triangle, but it works for any isosceles triangle. Okay. So we put this in our calculator.
7.134.
So 7.135 square inches. Question on those first 5 examples. Anything needs to be cleared up? Or read something. All right, example 6. Let's find the measure of arc ADB. Now, what are we given here in this picture? What are the two things that we're given?
And the length of the
Okay. The radius and the arc length of the minor arc. Okay. And we want to find the measure, not the length, the measure of the major arc. So if we knew the measure of the minor arc, could we get the measure of the major arc?
yes.
Sure. All right, subtract it from 360. So let's concentrate on finding the measure of this minor arc, because that's what we know. We know the arc length of AB, right? We know that, and we have a formula for that. All right, so we have a formula. The measure of arc AB over 360 times 2 pi r. That's the formula we're given. It's right there on the front page. Well, we know the arc length of AB was 7 pi. 7 pi equals. We don't know the measure of arc AB. But we do know the radius. The radius is 19. So how many unknowns do we have in this equation? 1. Okay, which means we can solve it for that unknown. Use some algebra and solve it. All right, so reverse order of operations. Do we have any addition or subtraction? No? Do we have any multiplication or division? Okay, so we have to get rid of the multiplication division by doing opposites, right? All right, so over here, we've got division by 360. How do we undo division by 360? Multiply by 360. And I multiply both sides by 360. When I do that, 360 and 360 divide out. Do we have any more division? So we have multiplication. Okay, so we're multiplying here. How do we get rid of multiplication? 5. So we divide both sides by 2 pi times 19. Divide by 2 pi times 19. Okay, well, let's see here. 2 pi times 19 divided by 2 pi 19. Those divide out. And so the only thing we have left over here is the measure of arc AB, which is kind of what we're looking for. Not exactly, but kind of. That equals 360 times 7 pi divided by 2 pi times 19. Now this is all just numbers, right? So I can very carefully type this in my calculator and get a approximate answer. And one other thing to note, we've got a pi in the numerator and a pi in the denominator. Pi divided by pi is 1. So the pi's can even divide out. We don't need to put pi in the calculator. We've got 360 times 7 divided by 2 times 19. And so, double check, we should get 66.316. You can get that exactly wrong. Is that what we're looking for?
Well, no.
Not exactly, right? What are we looking for? The measure of arc ADB. We're looking for the major arc. So we want 360 minus the measure of arc AB, the minor arc. So 360 minus 66.316, and we get 293.68. All right. So if you look at the assignment, there are 10 problems, but number 8 and 10 both have an asterisk because they're a little more challenging, I suppose. So I want you to do everything except for those two, and then work on those two. Okay. All the answers to everything except for 8 and 10 will be in my key. Those last two, I'm not going to put answers here. Those are the challenge subjects. Okay. Sure point. Yeah. You got somebody in front of you. Okay, so go ahead and get started. Start with number 1. What? Yeah, go in front of you.